If 6 inches and 8 inches are two sides of a right triangle, what lengths might the third side have? All right. Now, I want you to notice, if you look at the problem here, as we've got it, 6 inches and 8 inches are two, didn't say legs, did it? It said two sides. It's a little open-ended, and notice a little hint there. I put an S in parentheses there, because actually there's two ways to look at this problem. We did not specify that this was two legs, although it could be. We didn't specify it was a leg and a hypotenuse. It could be. Certainly can't be two hypotenuse situations, all right? So we know that much. So let's see what's going to happen. We know the Pythagorean theorem says a squared plus b squared equals c squared. And remember that a stands for a leg, b stands for another leg, and c stands for the hypotenuse, all right? And in order for the right triangle to happen, this has to be true, all right? So the values have to pop in there and be equal on each side there, all right? So let's first of all, let's suppose that 6 and 8 are our a and b values, okay? And we're going to put the 6 in and square it. We're going to put the 8 in there and square it. And let's pop it up here, all right? We've got 6 squared, which is 36. And we've got 8 squared, which is 64, which gives me the c squared, all right? Now, quick addition here, 63, it's not 63, I get a little, I felt like I was dyslexic there for a minute, I'm sorry. 36 and 64, we've got a 100 on that. That's what we're looking for. Equals to c squared. Take a root of that. That's going to give us 10. That's our square root. We would do it to both sides. There we go. So 6 and 8, and that makes the hypotenuse 10. All right, when c level, there we go with the hypotenuse. Now, I said lengths. Remember, there's two options. So let's suppose one of the legs is missing. All right, so we've got a squared. Let's put in 6 squared equaling to 8 squared. Now, folks, you know that I can't put 6 there and the 8 over here because the hypotenuse does have to be the longest side. So that's why I put 8 out there. So there's not 3 ways to work this, only 2 ways to work through this problem. So let's see what we've got. We got a squared plus our 36 equaling to 64. There you are. There you have it. And you know what? We're going to subtract that 36 this time. We didn't add it because we're going across the equal. So we're going to subtract 36. See that? And that's going to leave with a squared equaling to, looks like 28. Now, 28, you know, it doesn't have a square root situation, but if y'all taking that Geometry 10 ready business, they're going to want you to make a root out of this and make it a radical form. So let's do that first. We're going to square root a squared equaling to root of 28. That breaks down into a equals, underneath there we've got 4 times 7, remember a perfect square, which is going to leave us with 2 roots of 7. That's what our a would be equal to in radical form. Now let's go quickly to the calculator. Let's see what we've got there. We have 2, let's see what that is in a decimal. 2 times, and we're going to say, the root of 7, I think you could just written 2 roots of 7 up there. You've gotten the same value, but I'm going to put it just to make sure because we're running on time, of course. There we have it, a little over 5. That's the root of 28. It is 5.29. 1.526. It's irrational. Remember that, folks? So it rambles on and on and on. We will round it off maybe to the nearest hundredth here. That would be about 5 and 29 hundredths. And again, that's approximately close. It rambles on completely. So we're just going to round off there. So that's your decimal form. There is your radical, simplified radical form, all right? Depending on what they're looking for, depending on what you're asked for, there's your possibilities. But notice the open-endedness, 2 sides. You don't know whether it's the 2 legs or you don't know if it's a leg and a hypotenuse. You got to take care of both.
For more math help, visit TNLearn.org.